Hi class, welcome to EdVantage. I'm Dr. April Strom, and what we're going to be doing here in this video is actually part 2 of a previous video where we talked about the changing quantities of volume and height for a cylinder. But here we have a different shape. We're going to actually look at and explore this type of shaped bottle, and we're going to imagine this particular bottle filling with water. So if you can, in your mind, imagine this bottle empty to begin with, filling with water all the way to the top. And it's got to navigate this kind of curvy shape here in the middle section and this kind of cylindrical section there at the top of this particular bottle. So in your mind, imagine this filling up. Now what I'm going to do here is actually try to graph a sketch that would mimic this particular scenario of the bottle filling with water. And I'm going to track 2 different quantities again here: volume of the water, so the amount of water in this particular bottle, as well as the accompanying height of that water in that bottle relative to that volume. So we're going to start off and imagine, all right, I'm going to put some amount of volume in this particular bottle, and let's say it gets me to that height of the bottle, okay? So some amount of water, call it this much, doesn't matter what the actual number is or unit, we're just kind of qualitatively looking at these scenarios. So I'm going to add some amount of volume in this bottle and I achieve some amount of height back out. So when I do that, I get maybe an accompanying height of, say, right about here. Now in the beginning, remember, it was empty, I had no volume and thus no height also in this bottle. So technically speaking, I had a point over here, 0, 0. Now, what I want to do here is continue imagining this bottle filling with water, but I want to add the same amount of volume in every successive adds to this bottle. So I'm going to add the exact same volume of water here. And now I want to think about what would that new height be. So the question is, would the new height be the same amount added with this second amount of volume added as it was the first time? Now consider the shape of that bottle though. If I add additional water, the same amount as I added previously, because this bottle is bowing out in this direction, I'm actually not going to achieve the same height as I did the first time, maybe a little bit less. So maybe I have something like about right here. And it's because with the wider bottle, I have more area in that particular bottle to fill with this water. Thus, the height isn't quite as much as it was in the beginning. So I cannot plot this particular second point achieving the same height as I did originally. I'm going to have, so we'll just put a tick mark here so you can see, this is as though it was on the axes here, as though it was the same amount, but when I add this volume for that shaped bottle, I'm not going to be able to quite get the exact same height I achieved originally back out. I'm going to get a little less, so maybe about right here. And I keep with this process, I keep doing this by adding water. So I'm going to add a third amount here, some amount of volume, and now I get, say, a height right about here. Again, same amount of water going in as the second and the first iterations, but unfortunately, again, because the bottle is bowing out, I don't achieve the exact same height as I did initially, or even in my second add of water. Instead, I get a little less height. So I have a third amount of water I'm adding. This would be a marker as though I was achieving the same amount as I previously did in the first one. I'm not going to get as much as I did in the first one in terms of the height back out. I'm not even going to get as much as I did in the second iteration of the height back out. I'm going to get a little less. So I'll have about, maybe right here. So you can see the amount added here is some amount. That's a little less in the next part and a little less in the next part, and you can get the idea. This is going to continue happening until when? Well, until I'm actually at the widest part of my bottle, right about here, where the diameter is the largest. So what's going to happen is for each amount of water that I'm adding to this bottle, I will achieve smaller and smaller heights back out until I get to this middle section of this bottle where it is the widest. Okay? So I'll put maybe one more marker here. If I add amount of volume, I don't quite achieve what I did in terms of height previously. I'll just add some height, but not as much as the previous amounts. So far I have some shaped graph that kind of looks like this. Okay? A curvy section here. And now it's kind of flattening out. I'm at the center of my bottle. And if I continue adding after the center of the bottle, now the shape of the bottle is coming inwards. And so as a result, some amount of water being added, let's say I'm at the center and filled, I've got all this water here in the bottom part of that bottle, and now I'm at the center and I'm going to add some amount of water. And then again, some amount of water. Well, what's going to happen is that same amount of water is actually going to bring me higher on this particular bottle. So the same amount of water might bring me to here. So we can kind of see corresponding changes in height for this amount of water being added is less than what I would be able to achieve in subsequent adds of water. And so because that shape is coming in, I'm sort of filling this bottle here and achieving higher and higher heights. So what happens now at this section of the bottle, I now start turning upwards a bit because in terms of the shape of my graph, because of the mere fact of the shape of the bottle allowing us to achieve greater heights with each add of water. And it behaves that way until I get to this neck of the bottle. And like in the last video when we had a cylinder there, every time I added some amount of volume of water to that bottle, I got exactly the same amount of height of water back out because of that shape. So what happens there for this neck part is I have a constant rate that's coming up. And so now I've got a linear type situation here with this particular graph that corresponds to that neck of the bottle. And so we can see essentially my shaped graph is what we would call concave down in this first section, and it corresponds to the middle of that bottle. And after that place, I now have a concave up section of the graph that corresponds to this top part of this curvy section of the bottle. And then now here, with this linear section, I have a part of that graph that corresponds to the cylindrical top of that bottle. So what's really cool here is now you can start seeing that in this section, we have our constant rate of change as we did previously for all things that are cylindrical. And that gives us our linear section. But in this section down here, this first one, because we have concave down part switching to a concave up part, we have changing rates of change in this particular section. So we'll call this the changing rates of change. And between those changing rates of change, from concave down to concave up, I have a special point in mind, say right about here, that happens to correspond to the center of the bottle that we call our inflection point. And this occurs, an inflection point, that is, anytime I have a switch from concave down situation to a concave up, or vice versa. So this is a little bit about thinking of quantities and how they're changing, particularly when their corresponding covariation of those quantities are also changing. The fact that the rates here are changing almost all the way through until I get to that cylindrical top of that bottle. And then I have a constant rate of change coming out. So thank you for watching.